Welcome to week 10. You should be continuing on with your final project. We just have one little assignment this week. It's called the Nutcracker assembly. You'll see it here on in academic content week 10. You have to download the instructions for it, follow the instructions, or follow the video which I have up on YouTube. Download the zipped parts file. Unzip the parts file. Don't try to open it inside the zipped file, or as the warning says here, it creates a temporary file that's read-only. So download it, unzip it. There's several files in there, like 9 files. Most of the assembly is already put together. One of the part files is an assembly file that's called assembly. So open that up and continue on following the instructions, putting in the last 4 parts. You then check the motion and fix the 2 errors, the 2 collisions. When you get that done, send me a picture of the assembled file, like you did with the hinge, and that will be the last homework assignment for the semester. When you open up the part, the Nutcracker assembly, it may look like this, black background. Just go up to shaded with edges and make it shaded. Then it should look solid like this. So we have everything's assembled down here at the bottom. This yellow link is not assembled. I think it looks like it was put into the assembly. Then you'll find that there's no assembly conditions on this part here. These are just floating in space, and the one part has to be brought in. So 1, 2, 3, and the arm part has to be brought in. Everything else is already assembled. So let's go to File and Modeling first. That will give you the right menu up top, and it'll make these parts editable if you need to. Then we'll go to Assembly, and let's see, let me also open up. Here is the Nutcracker ASSM at the end for assembly. So that's the part that I have open right now. Here's the assembly instructions for the Nutcracker. The first slide here should look familiar to you. Second slide, let's talk about load options. So download your parts. You should have that done. Start NX. Load options, menu, file, options, assembly load options. So let's go to that. Assembly load options. In its simplest form, your NX program should have this load options from folder. What that means is that when you open an assembly file like I have here, it looks in the same folder for all the parts in the assembly. Now there is a way to put the parts in one folder and the assembly file in another, and have the program point to the parts file folder. But the easiest way is to just have it set here from folder, and put your assembly in the same folder as your parts. And then if you want to send somebody your assembly file, make sure they also have a copy of the parts files, and it'll find them. If you do not have the assembly file in the same folder as the parts file, when you open up the assembly file, it'll probably say cannot find this part, this part, this part, this part. The assembly navigator shows all the parts that are in the assembly right now. No constraints are shown in here because assembly was put together. Some legacy constraints called mating conditions. So the first time we go into this, it's going to probably tell us to update it. Here we go. So I went to assembly constraints, and it says the current work part already contains mating conditions. That's what they used to be called, mating conditions between parts. We don't want to delete those. We want to convert the mating conditions. So work part in loaded children, yes. Okay, conversion has been complete. Now you'll see that there are constraints in here, quite a few of them already, for all the parts that are already constrained. We want to continue on and constrain the rest of these parts. This part here, follow the instructions starting at number 6 here. We want the mount number 8 and the shaft 2 put together. So pictures of the names are here. We're going to put in the shaft number 2 is that reddish part. We're going to put that through the mount. Then we're going to put the crank handle onto the end of it. Then we're going to put the arm on here and link the arm to the link, which links to the rod. So first, the mount and the shaft. It says to move the shaft, use the move component command. So we're going to reposition the part on the screen to put it closer to the mount where we're going to place it. So the move component does two things. It can cause motion between parts. It can also just take a part and move it in the assembly somewhere closer to where you're going to be assembling it. We then click on assembly constraints. We're going to use the touch align and first center axis to put the shaft into the mount. Then we're going to apply that. We're going to then create a distance from the left side of the end of the shaft to the mount, 1.5 inches, and then apply that. That'll be the only two constraints for the shaft. So let's use the move component. Click on that, specify orientation, and just click and move this down to where we're going to be working on it. And say OK. Then we're going to go to assembly constraints, touch align, and first center axis. Remember this one, we pick the surface of the cylinder, the hole, that face, put it inside here, it lines it up. If it looks right, you say apply. Second constraint is a distance constraint from the end of the shaft to the left side of the mount, 1.5 inches. The shaft is now free to turn, but not slide left, right, up or down. Now we're going to put the crank handle on it. Again, touch align and first center axis. I always like to put shafts on the holes, or line up shafts or line up holes first. And that puts them in the correct orientation. So in first center axis, we'll pick this. Be careful you don't pick the chamfer by mistake. And the outside of that. This is about how the instructions are telling you how to do it too. You can follow the instructions or follow this video. Or go it alone if you want to try it. So that puts the shaft in. Notice the flat spots. Okay, are not lined up yet, but we're going to apply the first constraint. Then before we stick it on the shaft all the way, we're going to line things up. We're going to use the parallel command this time. Now here's the thing about the shaft and the hole. If the shaft diameter is exactly the same diameter as the hole diameter, and the distance from the center of the shaft to the flat edge, that distance is the same as from the center of the hole to this flat edge here. If those distances are equal, then those two flat edges will actually be touching. And you could use a touch align command to align those two flat edges. But if the distance from the center of the shaft to the flat edge is different than the center of the hole to the flat edge, you cannot have those two planes touching one another and have the shaft centered. Okay, those two constraints would be in conflict with one another. But we can always have two planes parallel to one another. So I'm going to make this plane parallel with this plane. Notice the crank rotates to do that. Now they can be parallel and not touching. I'm going to apply that, and then I'm going to use a distance command to make the faces flush with each other. So that to the end of the shaft. Make it 0. Or you could use touch align. There we go. Let's go to home. Let's go move component. Let's see if it works. Make sure the crank handle is pointing to the left. And to make this move smoother, we're going to click on Move Handles, and we're going to make sure this is on Arc Center Snap, and click this to the arc center of that shaft. Turn your handles off, and then we can grab this yellow ball here, click and drag, and everything should move smoothly. Notice the handles are always the same size, so that should be moving. We're then going to bring in the arm, so we're going to do add, and the arm is, it's not loaded yet, so we have to go get it. There's the arm. So we're going to bring this in by constraints, so say OK. The first constraint, oh, let's preview a component in main window. Notice it comes in randomly, and there it is over there. The instructions say to line up the flat edge that's painted green here with the flat edge that's painted green here. If you do that, it'll rotate this part in the main window, but you won't be able to tell if you're actually in the right orientation or not. So I always go to Infer Center Axis first. And click on this. And click on that. Now it moves it over here and puts that first constraint in. I'm going to say OK, that looks right, but it's too far on the shaft, so I'm going to move. Pull it off here. If it's on top of the shaft, it's kind of hard to line up the flat green edges. Let's go back to constraints. Instructions also say that you have to line up those flat planes, so I'm going to do that. So parallel. This one, parallel to this one. There's two possible solutions for this. If you hit the reverse last constraint, they can be parallel but on opposite sides. So if you use parallel, make sure it brings it in, parallel on the correct side. Apply that constraint. And then I'm going to use a distance command. It wants the shaft, the end of the shaft, and the right side of the arm here to be 0.25 inches. Okay, negative 0.25 inches. Wants it sticking out of there like that. Or you can do the cycle last constraint. You'll see it moves it around. So if you have it on there, it's kind of hard to remember which way is positive and negative. The vector is pointing, I believe, this arrowhead, the vector is pointing in the positive direction, so that's why it went inside. The shaft was inside first. But you can just cycle it. So that's in the right location. Let's say OK, and let's move that. If you have parts that are movable, you want to, until you get good at this and get confident with what you're doing, you probably want to keep testing the motion to make sure it's working correctly. Also watch your constraint symbols here, okay? If they turn red, that means they're over constrained. If they're over constrained, oh, yeah, I got some constraint wrong here. Little red X's are giving me a problem. So I did something wrong over here. Let me back that up. Control Z. Okay. If you get constraints that are conflicting, they turn a red X, you want to fix it immediately. Don't keep going, because they'll just keep misconstraining, conflicting constraints with more and more parts. So I'm going to go back to the constraints here and do a distance command from here to here, minus 0.25. Say OK. Keep your assembly navigator up with your constraints open, and do not ever let your constraints conflict with one another. Troubleshooting constraints is very time consuming sometimes and hard to do. If you have two conflicting constraints, you can try suppressing one, see if that fixes it, and if that's a problem, you pick the correct one to constrain. it's kind of hard for me to explain troubleshooting on this. So what I want you to do is avoid having conflicting constraints to begin with. That's always the simplest solution, is don't make the mistake. So keep your constraints open, watch for conflicting constraints as you build your part. Okay, so we have those 3 parts on here. Now this part here, the link, the yellow link, can be moved, you'll notice. Okay, there's nothing holding it in its place there. So we're going to go assembly, touch a line in first center axis again, and we're going to put this hole on this shaft. Notice it moves the whole link because it's not been constrained here. We're going to say apply, and then we're going to apply the other hole to one of these holes on the rod. It swings everything around to make it fit. Now we have to go center the link inside the rod here. I call that the yoke. So let's say apply that last one and then do a center 2 to 2 like we did with the hinge last time. We're going to pick 2 sides and put it within 2 sides. And say OK. We do not have a pen for this hole. Doesn't matter, it still works because this is not reality, it's just a model. Click on the crank. We're going to do movement, orientation, that's still stuck on there, good. Let's change our collision action to highlighted, and then let's move it. Okay, we see 2 things. We see the smasher plate and the hinge, one of the hinges, which is on the back of the smasher plate there. Those are always in collision, so we have to fix that. And as we rotate this around, we see that the pin and the link, the shaft, sorry, and the link are hitting right there. They're turning red, they're overlapping. Since I put this together, I should remember how to fix that. So what I need to do is take this whole shaft with the arm and the crank. They're all going to go to the left. I do that by changing this 1.5-inch distance command. This end of the shaft and the end of the yellow mount, move it 1.6 inches away. So one of these distance commands, I think it's that one. Double click on it, change it to 1.6. Watch the screen. Everything moves just a smidgen to the left. Say OK. And now you notice these 2 parts are not touching anymore. So that will fix that. Over here, turn this and zoom in on it. Hit F8. What we have here is, let me change this to hidden edges. Dim edges, there we go. Zoom in. Notice this part and that part, they overlap a little bit. Zoom in, see that? So the easiest fix, well, let's see, we could take the smasher plate and move it up, but then these 2 pieces wouldn't fit right. So the easiest solution for this is to take this edge blend here and make it a smaller radius. So I'm going to double click on this hinge part, and in order for this to work I have to be in modeling. So if you're not in modeling, file, click on modeling, and usually it's on the top here. I am in modeling, so I don't have a problem with it. So go into modeling. I'm now in this part. I'm in the part navigator. I'm in the part of the hinge. There's the edge blend command. Either click on it here or click on it over here. Double click on it. Again, you have to be in modeling to do this. Change the radius to 0.1, 1/10 of an inch instead of 1/8 of an inch. Say OK, and then you'll notice that hit F8 to square it up. It misses now. So we can go back to your assembly navigator, double click on your assembly. By the way, you should be in the assembly PAU Nutcracker ASSM, the assembly file. You shouldn't have created your own assembly file. Use the one they have. So that's fixed. Now we should be able to do the move component with the highlight collisions on. And it should run smoothly like that. Okay, one more thing. So in your final report for your project, you will need at least one assembled assembly view. You will also need an exploded assembly view. So let me show you how to make an exploded assembly view. Up here under exploded views, under the assembly tab, you click on that. You click on new explosion. Say OK, give it a name. And then we have to go back into it again, exploded view. Now that we have a new explosion started, we can say auto explode. This is the simplest way to create an explosion. We're going to just say select all, say OK. Give it some magnitude, about 10. You'll have to play with the magnitude to find out what works best for your part. Now when it does this, it explodes the parts kind of randomly. Sometimes though, all the parts go in the same vector with the same magnitude, and they end up in the same relationship with each other. It's not a pretty explosion, it's kind of random. What you'd probably want to do, let's undo this, is maybe if you only have a few parts, which you guys would have, go to exploded view, go to edit explosion, and you can take one part. If you want to click on the part, select object, click on the part, move part, and then you can move it. Click on the arrows to move it, and you can pull it apart one piece at a time. Say apply, select the object, click on this one, move the object, move it. Oh, I didn't want to pick the other white one. Might have to cancel out of it. Edit, and pull it apart. Move it this way. I don't know how to unselect it, except by just saying OK and cancel. There might be a faster way to do that. And then we'll pick this and move the object. Okay. So you can do this, edit apart. Now there's one other thing you can do. Loaded view. Oh, here it is right here. Trace lines. Trace lines you can pick like middle of arc center here and arc center here. And it puts a trace line between it. Kind of like shows you where they go back together. And if you move a part, however you move that part, those trace lines will stay connected. Okay? So you'll need an exploded assembly view. This is what I want you to send me for a picture. I want you once you get your assembly to work, the motion to work, I want you to explode it. Fit that picture there, explode it, and send me a PDF. You'll have to create one of these for your final report too. Oh, so for your final report, what you want to do is you want to turn off your edges, so just have shaded. Final report, you want an exploded view that looks nice. You probably want to turn off, right-click on constraints, turn off your constraint symbols if they're showing up. Okay. You might want to also go to rendering and do a rendering of it before you do a screen capture. If you can highlight anything else and say hide it, did that work? No, no. Got rid of part of it, but not all of it. Oops, wrong thing. So you can do a rendering if you want a prettier picture. So hide what things you can. You can also hide coordinate systems by going, let's see, menu, I think it's under format, WCS is World Coordinate System, and display off. So that gets rid of the coordinate system. You can use your directions here to finish the part, or just follow the video, or try it yourself, your choice. You'll learn any way to do it. But editing the constraints is the tough part. If you get something in conflict with one another, there's different ways you can do it. You can try, and it's kind of hard to show you how to troubleshoot without having an error. But if you had 4 parts that were in conflict with one another, you can try suppressing one of those that has a red X on it, and whichever one you suppress and it fixes all the constraints, all the red X's, the conflicts go away, that's the one that you probably want to delete and then recreate to fix it.